Hello everyone, welcome to Neural with Mohit. Today we are going to build another interesting application where you will be able to, have a conversation with the LLM, but not through text, through your voice. So it will be like a speech conversation where you will be giving instructions or asking queries to your model, and the model will also be replying to you as like a voice assistant for you, right? So let's dig in, understand like how we are going to build it. Let's first see a demo, and then after that we will see the architecture of that. Let's move to the demo. Hey, what is your name?
My name is Friday, Mohit.
Okay, great. So Friday, tell me about transformers and generative AI.
Mohit, transformers are a type of neural network architecture introduced in 2017, widely used in generative AI, particularly in natural language processing (NLP) tasks. They're known for their ability to handle sequential data, like text, and have been instrumental in developing models like BERT, RoBERTa, and other language models. Transformers rely on self-attention mechanisms to weigh the importance of different input elements, allowing for efficient processing of long-range dependencies in data.
Okay, great. So can you please tell me about agentic AI design patterns?
Mohit, I don't know about agentic AI design patterns.
Okay, great. Can you tell me about agentic AI design patterns?
Mohit, agentic AI design patterns refer to principles and guidelines for designing artificial intelligence systems that can act autonomously and make decisions. They focus on creating AI that can perceive, reason, and interact with their environment, often using agent-based modeling. These patterns help developers create more intelligent, flexible, and adaptive AI systems.
Okay, are you capable of doing a web search?
Hi Mohit, I don't have the ability to perform web searches in real time. I can provide general information and answer questions based on my training data, but I don't have direct access to the internet.
Okay, so what data are you trained on?
Mohit, I'm trained on a massive corpus of text data, including but not limited to books, articles, and websites, up to a certain point in 2023.
Great, I think I have all the information that I need. I would like to exit the conversation now. Okay, so now let's dive into the architecture of this application. So what we are doing over here is, and like here in this diagram, you are able to see one pass of that loop, right? So you must have seen that the conversation is going in a loop for you. Once you gives a query, and then when LLM gives you a response, after that again it waits for you to give another query, right? And once you are done with all your queries and you say that, I'm done with my queries, I want to exit and all, at that point the LLM will break the loop for you and it will exit the conversation for you, right? So what we are doing is we are checking one pass of that from here, and you can assume one exit like one exit scenario as well, after which the user will not be ask for any more queries from their side and the conversation will be done, right? So what happens is, when we start the program, when we call the function for the first time, so we start recording our speech, right? So our speech record function actually detects whether the user is speaking or not, and we have a delay of 1 second over there. So if the user stops speaking, right, so what we do is we assumes that the user is done from their side for the query, and then we go ahead and save the file, right? So if you take a very long pause, you may experience that uh, like it has stopped listening to you, correct? That is the reason, like what we have done is we have actually added small delay from our side, which is like if you do not speak for let's suppose a second or two, then we assume that you are done talking, and we'll be passing your query to the LLMs. Okay, so how it happens is, after you are done speaking, so what we do is, we save your audio file, basically a wave file, WAV file, right? And then it is passed to a function where we use whisper over there. So whisper AI you must have used. If you have not used, then you will see today like how we use that. So there when we send, so we can send along with that the language that we are sending. So we are sending in the English. So what we will be doing is we will be converting our audio to a text, Okay, because like the LLM that we are using, so the LLM understands text, right? So what we are doing is we are taking the audio, we are extracting the text from that audio, and then that text we are passing to the LLM. Okay, and this text thing you must have seen in, like, like let's suppose if, even if you have attended a Google Meet and all, you must have seen that while somebody is speaking, you see a closed captioning coming at the bottom, right, where it keeps on from your speech, it keeps on detecting that what you have said, the words and all are printed over there. And sometimes you might also notice that it is not very elegant in catching those words, right? Because Whisper AI is kind of old. Nowadays there are other solutions as well, like you can use 11 labs, but the thing is you have some free credits over there, and after that it is paid, right? So if you are going for a paid solution, then you can use that also. This particular application is using completely free solutions available, right? So you will be using that right now here. Okay, so we'll be using the Whisper AI to convert our audio file to a text file, and then that text is sent as a user query to our LLM, right? So in our previous video, you have already seen how we use an LLM with Groq. So here we are doing the same thing, the same LLM we are using here, and we'll be using the same Groq file, right? So same Groq API will be using, the LLM we are using, and what this will be doing is this will be generating a response for you, right? So once the response is generated, so it will be giving you an English response, right? And it will be in the text. So what we'll be doing is we will be converting that text to a speech. And once that text to speech is done, then that speech is actually played for the user, right? And again, the next loop starts where it again waits for you to speak something. You will be doing this thing, and you will see this thing happening in a loop, unless you say that you want to exit the conversation, or you show a negative like signal towards the conversation, right? So in that case, you will be exiting the application, right? So now let's understand the project, and let's dive in the code and see how we are going to use this thing, right? So I have already built this project for you in advance, right? So when you will download it from the GitHub, you will see one agent folder, and this is the heart of this project, right? Rest everything is as I said, that I will be building the fast API for you, and I will also build the UI for you, right? So that I will build and add later. For today, let's jump right in. So what I was doing is, when you run the program, right? So you must have noticed in the video that when you run the program, we run it with UV. In our previous video, you have seen that I use UV for creating a virtual environment and actually executing my programs. So this is the command that you have to run. You will be saying UV run agent folder, which is this one, and inside that you will be running the agent interaction.py, right, which is this file. Okay, this has this code, and when you run this file, it actually calls this particular function, right? So we'll go to this function, and before we actually go to this particular function, let us understand that prior to this, what we are doing. In yesterday's video, you have already seen that we are using the Groq for LLMs, right? So what I have defined is I have defined a Groq key in my environment file, which is over here. You will not find it in the GitHub project. You have to create your own environment file, and you have to add a key like this and then add it, right? So after you have the Groq key there, you will be loading your Groq key, right? Using the load environment, and then you will be creating a client for Groq, right? Okay. Apart from these, if you will see, we are also importing few functions. These are the custom functions that I've created, and once when like we will be going to that, we will go to that and understand. First, let's understand the flow ones. Okay, so what we are doing is we are calling this Groq interact, right? And here you will notice that I am running a loop which is with true. So it means that it's an infinite loop, right? And the only exit condition is this, right? So when my response comes as exit, in that case, I will be exiting this particular loop. Okay, so now let's understand that what is actually happening inside this loop. So first thing that we are doing is we are saying that record the speech and convert to text. So in the diagram we have already seen that what we are doing is when the user speaks something, we create an audio file. From that audio file, we give it to Whisper. That Whisper transcribes it to a text, and that text is being received here. We will understand this function as well. But first let us understand that what is happening in the flow, and then we will go inside the function and we will see the functionalities there as well. Okay, so once you receive the text, then after that what you will be doing is you will be simply calling your model, right? And for calling your model, you have seen in yesterday's video already that we have to create one message array, and in the message array we are using two roles over here. One is system, where I'm setting up all the instructions for my model, right? And another is role from the user, where we are giving that particular query that the user has asked, right? Now let us see the instructions, because you might have noticed in the recording that I've played when I was interacting with this LLM, that the LLM actually said that its name is Friday, and then it also said that hey Mohit. So how does it know that Mohit is interacting with it? So I have actually given those instructions over here. Like I've said that you are a helpful and factual AI assistant that can reason over English text, right? Your name is Friday. My name is Mohit. Always address me with my name. So that's why you have seen that in each response it is addressing me with my name, right? Your task is to answer the user's question. Explain in brief. Do not make it very long. Keep it crisp and informative. So I have given this line because it is giving me a like audio response, and I have to wait for that audio to complete for you to go to the next question and do a recording. So that's why I asked my LLM to keep it very brief. However, if you want, you can actually ignore this line for yourself, right? Now, if you do not know something, then answer that you don't know, right? If the user shows interest to exit the conversation, then return just exit. And this is the thing which I am actually comparing over here. If you will notice, right, I'm converting it to lowercase and then I'm saying exit, right? Do not give options for follow-up question. You do not have memory. So why I have written this is, sometimes when the LLM gives you the response, it also adds a follow-up question on that. But since we are not carry forwarding the previous conversation in so because of that reason I have asked it to not do this particular thing. However, what you can do is you can actually keep the previous response from the LLM and pass it as another instruction over here in the system itself, and then at the end you can put the user query. Okay, so now let us see what happens after that. So we give it to the model to actually give a response. So once you receive the response, that response is actually printed on this terminal that you have seen as well. And what we do is, as I said that in the diagram you must have noticed. So if you remember the diagram, right? So what we do is, when the response is received, then it is converted to audio. So the text is converted to audio again. So the same thing you will see over here, and you receive a result, and we are just printing it for the sake. You don't need to do this, right? This is just to give you that okay, the LLM has finished conversing. Okay, now let's understand the important part of this, the another important part of this, which is like this particular function, right? So we will go to this function now. You will find this function in this speech to text. So speech to text, because here the user is speaking and then we are converting it to a text file, right? So let us understand that how this function is working. So as I have said, like we'll go from the beginning first, right? So we have imported few libraries. Whisper is there for transcribing your text, right? Wave and PyAudio and Web RTC VAD are there to record your audio. Okay, and then here we have given few configuration. You can keep it as it is. If you want to change, you can change this particular thing to a delay or whatever you want. So this is a delay in seconds, right? Whatever seconds delay you want. And then this is the aggressiveness for this to actually take a decision on this, right? Okay, so now let's understand this particular function first, which we are calling from our main agent function, right? So what it is doing, it is calling record voice until silence, right? So we'll come over here, we will create an audio object, we will open the stream, and you will see on the terminal that it is saying that it is waiting for the user to speak, right? And the moment you will start speaking, it will say that speech detected, right? And when you will turn silent, in that case it will say that silence detected, stopping the recording. Okay, and when it is recording, so at that time you can see that it is creating all this stream, it is creating the data here, and then it is checking that the speech is there or not, and then going forward again and again. So this is also an infinite loop till you keep on speaking. At the moment you stop, it will break from this, and then it will say that stop the stream, close it, and terminate the audio, right? And after that, what it will do is, since it captures everything in frames, so those frames will be now joined and it will be returned, right? So here you will return all the bytes from the audio, and we will see that if it is too short, then we will say that it's too short, we cannot go ahead. But if it is not short, then what we are doing is we are storing it at our end, right? So you will notice that I am storing it in the recordings folder. So if I'll go over here and if I'll show you, so you will see this, there are a lot of recordings over here. So as many conversations you will have, those many files will keep on accumulating over here. Okay. So we'll come over, we'll give a file path. That file path will be saved to a place, and then after that we will say that transcribe this with Whisper. So now here we are going to use the Whisper API now. Okay, so what we will be doing is we will be saying that load the base model of that, right? And after that we will be transcribing it to English. You can give a language over here. Since I'm speaking in English and I know that this is the particular language, you can actually go to the site and see all the different languages that Whisper supports, right? And you can actually give any of those, and then once it is done, you have the result. Then that text is actually returned. So it's a kind of dictionary from which I am extracting the text, right? Okay, so once I receive the text, what I will be doing is I will be returning this text, which you will see over here is used as the query, right? Now this we have already understood. The remaining part was this. So let's come to this particular function. Here you will see some commented code. So you can actually use the GCTS library also. It has a different voice, right? And here only, like let's suppose you want to use, you can use 11 labs as well. So there the voice is much better. It is less robotic. Here you might have felt that it's a robotic voice, but you can use some of the paid subscriptions also. Okay. So this is also a working solution. If you want, you can use this as well. Here the only thing is you cannot control the speed. So here we have only two values for the speed, whether it will be slow or fast, right? Rather, what solution that I am actually using, there I can control the speed from my side. 200 is the normal speed, and more you will increase, you will see that slightly faster it will start speaking for you. So I have kept it 210 at the rate of 210, and then I started running this particular thing. So this is how it was working, and you have seen like how you can actually build this particular application. It can be a really good application for your college project if you want. Like in the college projects, teachers generally ask, right? So you can actually show an LLM based solution, and if you build a beautiful UI on top of this along with the fast API also, let's suppose, right? So you can actually showcase a real good project, and you can actually create this project and add it to your resume as well. For any college student, it will be very helpful, right? So I hope you liked the video. So if you have liked it, I would request you to please like it on YouTube, share it with your friends so that they will also know about how we can use an audio based conversation with the LLMs. And I would request you to please subscribe to the channel as well.